Hi guys, today I will use the radio communication tester to show you how to test a voice radio station. This is the Ceyear radio communication tester. It's portable, small-size design. This unit is a C model and covers a frequency from 1 MHz to 3 GHz. These two BNC connectors are for oscilloscope. These are BNC connectors for audio input and output. This is output for the IF generator, and this is the N-type input-output connector for TR signals. The last one is for the internal input. These connectors are configurable for different testing purposes. We can use our finger to select different functions, such as transmitter test, receiver test, communication test, demodulation, spectrum analyzer, real-time spectrum analyzer, power meter, IF generator, and so on. In this video, we use the transmitter and receiver test functions to test a voice radio station. We set the radio station to work at fixed 80 MHz. This is the audio port, including the voice input, output, and talk switch. This port will connect to the tester's audio in and out, and this is the internal port. We connect this port to the tester's TR connector. Firstly, let's test the radio station's transmitter performance. We use the finger to choose the TX test function. The tester automatically creates a demodulation and audio generator window. The tester can generate an audio sine wave signal and send it to the radio station through the audio output port. The radio station uses FM to modulate the audio signal to the 80 MHz carrier. The high-power modulated signal will be transmitted to internal port and then to the tester's TR port. The tester will demodulate and analyze the received 80 MHz signal and tell you the radio station's transmitter performance. Here, we set a sine wave 1 kHz signal with a level of 5 microvoltage. We select the TR port to work at receiving mode. We tick on the output. The R light is on now. Then, we set the carrier to 80 MHz and select FM demodulation type. We select a proper filter for the 1 kHz audio signal. We press down the talk switch. The radio station transmits a high power to the tester. We can see the perfect sine wave signal with excellent FM modulation parameters, such as modulation rate, distortion, SINET, SNR, and so on. Of course, we can set different frequencies and different wave types to achieve different test purposes. Secondly, let's test the radio station's receiver performance. We choose the RX test. The tester automatically creates the IF transmitter and audio receiver window. In this test, the tester will generate a FM modulated signal and send it to the radio station. The radio station will demodulate the signal and get the audio signals. Then, the audio signal is sent back to the tester's audio in port for further analysis. In this test, the most important parameter is the radio station's sensitivity as a receiver. We switch the IF output from generator port to transmitter port. The light is on now. The IF signal is set to 80 MHz with 1 kHz FM modulation type. The deviation is set to 5.6 kHz according to the radio station's requirement. The radio station sensitivity is declared to be minus 110 dBm. We set the IF amplitude to minus 105 dBm. We tick on the IF output. We can see a good shape sine wave, and SINET is 22 dB. We keep decreasing the IF amplitude slowly. We can see the SINET is also decreasing. When the audio's SINET deteriorates to 12 dB, This RF amplitude will be the radio station sensitivity at the receiver. Now, the wave distortion is about 10% and its shape is not acceptable. We can see the actual typical sensitivity is about minus 117 dBm. You can also see other parameters on the bottom. That's all for today's radio station test. Thanks for watching. Bye.